Okay, today we're going to do a quick refresher on some of our measures of central tendency, which are mean, median, and mode. And then we're also going to talk about some measures of what's called dispersion. So first thing let's talk about is mean. Okay, the mean is the average. You total up your data items and divide by how many data items you have. And that, from now on, in math is going to be referred to as X bar. Okay, and that just means the mean, which is the average. The mode is the value that occurs the most frequently. There can be one mode, there can be more than one mode, or there can be no modes. And then the median is the middle number, and then this is important, when the values are written in numerical order. If the data set has an even number of values, the median is the mean of the two middle values. So let's talk quickly about this first example, which is the heights of 8 various waterfalls in the state of Washington. So let's go ahead and find the mean, median, and mode, and then talk about which method or measure best represents the data. So the first thing we have to do is we have to add these numbers up to get the total, and then we will divide it by 8 because there's 8 numbers. So pause the video, add up the numbers, and then come back and we'll check it. Okay, you should have got your sum as 10,752, and then when we divide that by the 8 waterfalls, we get 1,344. So that's the mean. Okay, we added them up, 10,752 divided by 8, and got 1,344. Okay, the next thing we're going to find is the median. That is the middle number. Okay, so what it was talking about earlier up here, we have 8 numbers in our data set. Okay, let's check to make sure they're in order, which they are. Because there's 8, there's not going to be an exact middle, right? We have 1, 2, 3, 4, middle, 1, 2, 3, 4. So to find the median, we need to find the mean of these two, which means we're going to add together 1191 plus 1,200 and take that sum and divide it by 2. And that gives us 1,195.5. And then the last thing we have to talk about is the mode. And the mode is the number that occurs more than the other numbers, and that would be 1,000. There are 2 waterfalls that are 1,000 feet. That is more than the other numbers, and so that is our mode. And then if we have to talk about which measure best represents the data, so let's go through and look. The mean does not best represent this data, okay, because we have this outlier, right? If our waterfalls are, every single one of them, all 7 are like 1,300 feet or less, then you have one that's twice as big, right, as my next largest. That inflated my mean, right? My mean would be all the way over here. Is that a good representation of all of this data? No, it's way too big. Okay, and then let's talk about the mode. The mode is 1,000. Are most of our waterfalls 1,000? No, right? It occurs more than the other, but that's not the best representation of all the data. So in this case, the median is the best measure of central tendency, right? The average isn't always the best way. Okay, if I were to ask, like if I was trying to convince my parents to buy a new pet, I'm going to ask people who have a bunch of pets, right? Because that's going to make my average really high, but that might not be the best representation of accurate data. Okay, the next thing we're going to talk about is dispersion. And a measure of dispersion describes the dispersion or the spread of the data. 2 such measures are called the range, which gives the length of the interval containing the data, and then something that's called the mean absolute deviation, which gives the average variation of the data from the mean. So the range is simply the difference of the greatest value and the least. So for set A, my greatest value was 11.32, and my least value was 10.62. So 11.32 minus 10.62 is 0.7 for set A, right? So this was the 100-meter dash times, and so the range of times was 0.7 seconds. And then for set B, okay, my slowest time was 22 seconds and 73 hundredths minus 21.37. So that is a range of 1.36. So we're just doing our largest number minus our smallest. Okay, this brings me to something super fun called mean absolute deviation. For mean absolute deviation, what we are doing is we are seeing how far each of the numbers deviates. There's an ant, that's awesome. Or how far away each of our numbers is from the mean. So the first step is to calculate the mean. Okay, we're gonna do set A first. So go ahead, take a second, use your calculator, add up all the numbers, and then once you have all the numbers, we're gonna divide it by 10. Okay, you should have got 110.7 divided by 10 numbers. We had 10 times, so that's 11.07. So this is the mean. And that's super, super important because to calculate the mean absolute deviation, okay, we're gonna do the difference between each of these times, right? This is x1 and x bar, which is the average. So we're gonna figure out what's the difference between 11.07 and 10.62. We're gonna figure out the difference for each of them. Okay, so you can use your calculator. Y'all, there is another ant on my desk. This is not good. Okay, now I'm distracted. Here we go. Okay, so let's see. For the first time of 10.62, I'm gonna use my calculator and I'm gonna do, 10.62 minus 11.07, okay? And that's a difference of negative 0.45. This is absolute deviation. So it's 0.45. Okay, then my next one is 10.94 minus 11.07 is negative 0.13, but it's absolute value, so 0.13. Okay, then we have another 10.94, so that's 0.13. 10.98, so 11.07 minus 10.98 is 0.09. Okay, and now we're at 11.05. The difference between 11.07 and 11.05 is 0.02. Okay, so you get the idea of what's happening here, correct? Okay, so I'm going to keep going. The next one is 11.13. The difference between 11.07 and 11.13 is 0.06. And then the difference between 11.15 and 11.07 is 0.08, 0.21, 0.22, and 0.25. Okay, we're going to use our calculator to add all of these together. Pause it and add all of these numbers together, and you should get 1.64, which we're going to divide by 10 because I had 10 data items, which gives me a mean absolute deviation of 0.164. Okay, the next thing I want you to do is do the same process for set B. Okay, so first thing, go ahead and calculate the mean of set B, add together all those times, and divide by 10, and then come back and check to make sure you have the correct mean. Okay, what you should have got when you added them all together is 222.26. And then we're going to divide that by 10 because there's 10 numbers. So 22.226, we're going to round to the hundredths. So 22.23. That is our mean, right? This is our X bar. So now what we're going to do is we're going to figure out, well, what's the difference between each of these times? So 21.37 and 22.23. So pause the video, and then you can come back and check. Okay, what you should have got, I'm going to write down the times, or the differences. 0.86 plus 0.83 plus 0 plus 0, plus 0.11, plus 0.11, plus 0.13, plus 0.37, plus 0.43, plus 0.5. And when you add all of those together, I wanted you to have them so if you make a mistake, you know where you can see which one you messed up on. But when you add all of those together, you get 3.34 as my total of all the deviations. Then I divide by 10 because there's 10, which gives me 0.334 as my mean absolute deviation.